In this video, we'll look at pictures and descriptions, and we'll take them and translate them into mathematical expressions and then simplify them. Which takes us to our one and only objective for this video, which is to translate descriptions and/or pictures, we'll do a little of both, into mathematical expressions, and then we'll simplify them. The only real big note for this section is that the word of means multiply. So when you see this in a sentence, in the English language, of is typically a word that we breeze right over. It doesn't tell us a whole lot of information. But in math, it tells us something very specific. It tells us the operation of multiplication. So hold on to that as we get into some of the word problems. Okay, our first example. So we have a picture, and we want to find an expression for the perimeter and the area. So basically, we're being asked two different questions. To find an expression for the perimeter, first we need to have the perimeter formula. So let's write that up at the top here. The perimeter formula, if you don't remember, P equals 2L plus 2W, where the P represents the perimeter, the outside of the shape, the distance around, and the L represents the length, one of the two measurements of the rectangle. The W represents the width, the other of the two. Really, they're interchangeable, length and width. Whichever one you start with, just continue with throughout the problem. And then our area formula is length times width. The dot means multiplication. And again, this uses the same information, the length and the width, ultimately giving us an area. Since we're looking for an expression for each of these, perimeter and area, we just won't have the P equals and the A equals. Those won't be a part of the picture. We're just looking for the perimeter, the other side of the equation, the 2L plus 2W and L plus W. So let's start with, for the perimeter, in order to get this expression, we need to know what L and W are. And from this picture, we have a length and a width. Like I said, you can label either one as length and width. Typically, people label the longer one L and the shorter one W, but it doesn't make a difference. So if we know what the length is and what the width is, we can take those two expressions, plug them into the formula, and get our perimeter expression. So we have 2 times our length is 5x plus 2. Now, I put these in parentheses. If we didn't put parentheses, it would look like the 2 was only multiplying by the 5x. So the parentheses is really necessary to show that the 2 is multiplying everything, every part of the length, the 5x and the 2. Okay, the rest of the formula says plus 2 times the width, which is 3x. Again, in this case, the parentheses, in this case, not as important. If you didn't put the parentheses and you just put a dot, I would hate to see you lose the dot somewhere along the way and suddenly view this as a 23. So I think parentheses are the safer route to go. Okay, so this is an expression for the perimeter of this figure. But our objective also asks us to simplify. So let's do that. To simplify this, we can distribute the 2, giving us 10x plus 4 plus 6x, distributing the 2 to this parentheses, and then combine like terms. We get 16x plus 4. Now, if when you combine like terms, you put the whole number first, followed by the variable term, that would also be fine. Either one of these is completely acceptable for a perimeter expression. That's one piece. The other piece is to then find an expression for the area. Area formula is length times width. Our length is 5x plus 2, and our width is 3x. So this right here is an expression for the area of this figure, but we're going to go ahead and simplify it. If you wrote the 3x in front of the parentheses holding 5x plus 2, that's also fine. It's the same thing. Multiplication can happen in any order. You'll still get the same result. So to simplify this, I'm going to distribute. Distributing can happen in either direction. 3x is still multiplying everything inside this parentheses, which gives us 15, and x times x is x squared, plus 2 times 3x, 6x. And again, if you reversed these two terms, that would also be completely fine. So that gives us an expression for perimeter and area. Okay, good first example. Okay, let's do another one similar to the previous one, but this shape looks a little different. So we want an expression for the perimeter and area again. We have perimeter and area formula. Let's start with just perimeter, and then we'll go back to area. Again, two separate questions. It might be the case that you're only asked to find one and not the other, maybe both, who knows? So we're going to find both for this example. Okay, perimeter of a rectangle works if we have specifically a rectangle. Since this shape is a little out or a little off of specific rectangle, we'll have to use a little bit of a different tactic. So perimeter is the distance around the entire shape. So we have 14 representing this side, x minus 9 representing this side, 5 representing this side, and x minus 4 representing this side. So in order to get the perimeter for this figure, we are missing two sides. We need those to be able to add this all together to get the perimeter. But we do have some information. So if we know that this side is 14 on the left, and that part of that length is 5, then the remaining piece must be what's left over. The distance from top to bottom should still be 14. So if this whole piece is 14 and a little piece of it is 5, 14 minus 5 gives us the length of the bottom piece, which must be 9. Minus 5 equals 9. Good. Okay, we also need the length of this little top piece, kind of the shelf piece, and we can use the same logic to find this distance. So just as we looked at this left side as a whole piece and subtracted out the 5, which was a portion of that piece, we can do the same thing with the two expressions. X minus 4 represents the distance on the entire bottom, the length on the entire bottom. And x minus 9 represents the length of this very top piece. So x minus 4, a piece of that is x minus 9, so the rest of it must be this little squiggly piece here. So we can do just what we did before, take the large piece, subtract out the small piece to get us the resulting piece. Okay, if we have this expression, the first one doesn't necessarily need to have the parentheses. It's there so that we can see very clearly exactly where it's coming from. This is a package deal that we started with, and we're subtracting out a package deal from the top. So we can, in our next line, kind of clear that out. But if the whole top piece is being subtracted, then we need to distribute that negative. So minus x and plus 9, negative times negative becomes positive. Then combine like terms. X minus x cancels. Negative 4 plus 9 is 5. So we find that the distance here is 5. Okay, now that we have all pieces, every portion of the outside of the shape, we can come up with the perimeter. So our perimeter is just adding up everything all the way around. So we have x minus 9 plus 5 plus 5 for the shelf piece plus 9 plus x minus 4 and plus 14. Got a little stacked, sorry. Okay, let's add those pieces together. We have like terms. Perimeter. not equals. We just want an expression. X plus x is 2x, and then all of these numbers. -9 plus 5 plus 5. Let's just add them on the calculator. Plus 5. We have another plus 9, minus 4, and plus 14. Gives us a positive 20. So adding up all these numbers gives us 20. So our expression for the perimeter is 2x plus 20. Okay. So the other part of the question, let's box this because that's definitely one answer we want. The other part of the question is to find the area. Area represents the shaded in portion of the figure. Perimeter is around the outside. And there's a few different ways we could find the area of this figure. Remember that the area formula in general for a rectangle is length times width. But again, we don't have a perfect rectangle, so we can't use this quite as clearly as we did in the last one. There's a few ways we could look at this. One way to look at it is to say, okay, what if I multiplied the x minus 4 by the 14? That would give me the area of this entire shape, including this piece over here, which actually isn't part of the shape. If we went that route, we would have an expression for the area of this entire shape, but this is not part of it. So we can get rid of this piece by subtracting the area of this piece out. If we can get the area for the entire figure, including this non-existent space, and then subtract this out, then we have the area of the given figure. All right, so let's do that. Let's start this way. Area. So the area of the entire rectangle would be 14 times x minus 4. And then we're going to subtract out the piece right here. The area of this piece would come from length times width, which is 5 times 5. Put parentheses. And then simplify. So distribute. We get 14x minus 56 minus 25. And combine those together. Minus 25 becomes negative 81. So the area for the blue figure is 14x minus 81. One way we could get there. Okay, another way would be to look at these as two separate pieces and add them together. Maybe you're visualizing this top rectangle and this bottom rectangle as separate pieces. You can go that route. If you go this route, you can find the area for the first piece and the area for the second piece separately and then add them together. So if we go that route, let's add over here. Area for the first piece. This will come from multiplying the length times width of this figure, this shape 1 at the bottom. And the length and width of this piece are x minus 4 and 9. We figured this one out at the beginning. Then simplify this so we can distribute. 9 gets distributed. We have 9x minus 36. Then the area for the second kind of chunk of this rectangle, of this shape, is at the top here, and its length and width are x minus 9 and 5. So we can multiply these together. We get 5x minus 45. And then to get the combined area of these two, we'll just add them together. Add 1 and 2 together. So let's add them under here. 1 plus 2. We have 9x minus 36 plus 5x minus 45. Combine like terms. We get 14x minus, let's make sure, 81. Completely different way of finding the area of the same figure. You absolutely can pick whichever way you want to stick with. If you want to do both, that's fine. But in any case, for perimeter and area, it was necessary to find these missing pieces, to find the lengths of the pieces that aren't explicitly written. Okay, looks good. Do the next one. Okay, next example. So we looked at 2 pictures. Now we're going to look at translating a description. So here is our word problem. 1,500 students are surveyed about their math courses. 28% are taking intermediate algebra, and 53% are taking college algebra. The rest are taking statistics. And then the question, how many students are taking statistics? So looking at this information, we know how many students total were surveyed, and then we have some percentages for intermediate algebra and college algebra. College algebra and 28% intermediate algebra. Okay, so sometimes it's easy to come up with a description for the answer before going any further. So the number of students, how many students taking statistics would be the percentage left over from 28 and 53. There has to be 100% students surveyed about their math courses. They're all taking one of these 3. I realize there could be more answers, but we're going to assume they're taking one of these 3. And it's that percentage of students taking statistics. So first, let's find that percentage. So if there's 100% total and 28% are taking intermediate algebra, that gives us 72. And 53% are taking college algebra. That leaves us with 19%. 19% of students taking statistics. If we can take this and translate this into an expression, a mathematical expression, then we have our answer. So 19% we can change into a mathematical expression. When we use percentages inside equations or expressions, we typically look at them as decimals. So we'll change 19%, move the decimal back 2 spots, so we'll have 0.19. The word of, remember from our notes, of means multiplication, 19% of students. So this says multiply of students. Do we have information about the number of students? Well, we know percentages for different courses, intermediate, college algebra. We also know that 1,500 students were surveyed, and that's who we're talking about here, 19% of the students surveyed. So this just gives us the number. The students surveyed were 1,500. Are taking statistics. This is what we're looking for. 19% of students are the ones taking statistics. So that's it. Multiply these 2 numbers together. 0.19 times 1,500 gives us 285. So the answer to the question, how many students are taking statistics? 285 students. In some cases, you'll be given different information. Sometimes you'll be given every single percentage. Sometimes the percentages will be presented to you in a pie chart. 53%. They still have to give you that information. 28%. And that leaves the remaining piece that we just found, the 19%, to be the ones taking statistics. So 19% of the whole population, which is 1,500, gives us 285, which is how many are taking statistics. Okay, next example. This one's a little bit more mathematically straightforward, and that there is no representation of what this information means. For some people, I know that complicates it because you don't know what we're talking about. For some, the word problem is out of the picture and we can just solve. So the directions for this one are to evaluate when x is equal to 4 and y is equal to -1. So this is our given expression, and we want to evaluate this expression given this information. So if we know what x is and we know what y is, it's as simple as plugging those things in and following order of operations. So if we fill in for x, we have 3 times x is being squared, so 4 is being squared. This is another case where the parentheses are not completely necessary, but especially when there's an exponent, I would suggest it. Okay, plus 5 times, and then y is -1, and that's being raised to the 3rd power. In this case, the parentheses is more necessary. Again, if you can visualize it without the parentheses, that's okay, but you run the risk of, when you write it like this, evaluating incorrectly. For this, it looks like only 1 is being cubed and then there's subtraction happening, but what's really happening is that 5 is being multiplied by -1 and -1 is being cubed. So this, no good. Okay, once the numbers are plugged in, then we follow our standard order of operations, PEMDAS, or maybe you've seen it as GEMDAS. The P standing for parentheses, the G being grouping symbols. And when we do have parentheses in this problem, they're not acting as a grouping symbol, so we don't have to worry about that first. Done. Next, we have exponents. We do have exponents in this case, so we should evaluate each of those next. We have 4 being squared. Remember, 4 raised to the 2nd power means 4 times 4. The number 4 multiplied by itself 2 times, giving us 16. So now we have 3 times 16. And we have another exponent, -1 being raised to the 3rd power. -1 to the 3rd power means -1 times -1 times -1. Carry out this multiplication. 2 negatives multiply and give you a positive. And then 1 more negative being multiplied in keeps this a negative number. And again, I would suggest the parentheses just because you might view that as subtraction. All right, so exponents is done. The next 2 are multiply and divide. Don't be fooled, even though you say PEMDAS, multiply and divide are on the same level. So you do multiplication and division in the order that you see them, from left to right. So in this problem, we do only have multiplication, so that's helpful. We'll take care of each multiplication. 3 times 16 is 48. Plus 5 times -1 is -5. At this point, you could have also written this line as 48 minus 5. They represent the same information. The first sort of says that you have $48 and you owe, negative being owe, $5. The second scenario says you have $48 and someone takes away $5. You're still going to end up with the same amount of money at the end. So to combine these two together, our last step is addition subtraction. And again, this isn't add first and then subtract. It's whatever order you see them in from left to right. You can view either one. It's one operation, so whichever way you look at it. You can type either one in the calculator. 48 plus -5 gives you 43, and 48 minus 5 gives you 43. So either way, you get the same answer, different way of viewing it. There's no preference on which way you should write it. It's always up to you. But our outcome, our evaluation of this expression is 43, given this information for the variables. Pretty straightforward. Plug in the numbers, follow order of operations, and get your final answer. Now, be warned that depending on the type of calculator, you may not be able to, and you might be able to, but I would still encourage you not to, type in everything all at once and have the calculator evaluate it. Some calculators will follow order of operations and get you this final result. Some are going to do it, as a calculator is typically programmed to do, will do the operations in the order that it's seeing them. So if the calculator, if you type this entire thing into the calculator, it would do 3 times 4. Take that number and square it. Then it would take that number and add 5. Then it would take that number and multiply it by -1, and that number and raise it to the 3rd power, which is nowhere near what we did following order of operations. So keep that in mind as you go forward. You can use the calculator, but just make sure that you're still following this order of operations to do so. Okay. Okay, so we're at our practice problems. This section, it's not a warning, but just be aware that the problems that we're doing in the video are not necessarily the only types of problems that you'll see in the homework or on a test. It's the general idea of things. So the homework for my math lab has quite a variation of problems that we just didn't have the ability to get through and really cover so many different types. And part of the goal of homework is that you expand on the knowledge from lectures. So go ahead and practice these two problems. Take however long you need, pause the video, go through them, and then we will go through them together in a moment. Okay, let's take a look at them. So our first question is similar to our first couple examples. Find an expression for the perimeter and the area of the figure. Perimeter and area, two separate considerations. So let's go with perimeter first. Perimeter would be the distance around. We have a little bit of information. We need the rest. We are missing the side on the right, and we are missing the piece at the top. To figure out the piece on the right-hand side, this time we are not given the larger part. We're given the two pieces that, if pushed together, would give us the height of this larger part. So in this case, there's no subtraction. In this case, we have 3 and 4 represented here. This and this gives us the total length, so we add them together. 3 plus 4, 7. Okay, for the other piece, the one at the top, we are given the long piece. We know what a portion of that is, so we have to find the remaining piece. This one will use subtraction. Let's write this up here. So we have the larger bottom piece, and we want to subtract out this portion to get us the remaining piece. If I have the whole length of it being x plus 11, if this part is x plus 5, the other part has to be what's left over. So that's what's happening with the subtraction. Plus 5. Okay, we can distribute, drop the parentheses in the first one. There's nothing happening to it. If there was something to distribute, we would. Nothing happening there. Negative distributed. Combine like terms, x's cancel, 11 minus 5 is 6. So the length of this top piece is 6. Okay, perimeter is just adding up all of those sides together. So add them in whatever order. Addition can happen in any order. 3 plus x plus 11 plus 7 plus 6 plus 4 plus x plus 5. And then combine like terms. So we have 2x terms, and then a whole bunch of numbers. 3 plus 11, 7 plus 6 plus 4 plus 5. We get 36 plus 36. And that's as simplified as this one will get. So this is our expression for the perimeter. Okay, and remember with area, you have two options. You can either get the area had we included this kind of ghost section and then subtract it out, or you can get the area of the two individual pieces. Okay, let's go with the big area and subtract it out. So if we want the area of this entire figure, we have x plus 11 being multiplied by 7. That gives us the area of this whole piece, including the piece right here that's not included. We can distribute, we get 7x plus 77. And then we want to subtract out the piece right here that is not actually included, which is 4 times x plus 5. Distribute here and combine like terms. We get 3x plus 57. If you went the other route, your work would look a little bit different, but ultimately you should still get 3x plus 57. Okay, all right, the second problem. The second problem says 15% of students don't like pizza, 30% like cheese pizza, 55% like pepperoni pizza. Of the 3,000 surveyed, how many students like any kind of pizza? Any kind of pizza could include cheese pizza, and it could include pepperoni pizza. So we have a percentage for each of those. We can add those together. That gives us 85%. So we know 85% of students like any kind of pizza. Translate this. 85% becomes 0.85 of becomes multiplication. You can make it a dot if the X kind of throws you off. And then the amount of students surveyed was 3,000. Carry out this multiplication and we know the number of students that like any kind of pizza. 0.85 times 3,000 gives us 2,550 students. So this is the number of students that like any kind of pizza, that like cheese pizza or pepperoni pizza, either one. Go ahead and go to my math lab, work on this homework section. If you have any questions, feel free to email me, come by office hours. I look forward to hearing from you soon.